So here what we want to do, we want to find the indefinite integral. So one of the things that you need to really be careful with is that you want to be able to convert everything just to a power, just like how we did with derivatives. But also it's really easy to take the derivative instead of taking the antiderivative. So remember that when we want to take the antiderivative of a particular power, we need to add the power by 1 and then divide it by the total answer, which was n plus 1. So a couple things here. Let me go ahead and just take the integral. Let me write everything as a power before I take the integral. So this is going to be 3y to the 1/3 power, okay, plus 4w squared, minus 1/2. This is going to be w to the 2/3. Okay, dw, okay? And now here what we want to do is just, let's go ahead and take the integral of each thing. So remember that the numbers aren't really going to do anything. We just have to make sure that we just take the antiderivative of the other parts. So this is going to be 3, then w 1/3, I'm going to add 1 and also divide it by 1/3 plus 1. Here the 4 is not going to do anything. The square, I'm going to add 1 and also divide it by 2 plus 1, minus 1/2. Then the 2/3, I'm going to add 1 and also divide it by 2/3 plus 1. And now remember that we also have to add the constant of integration, just c. Okay? So 1/3 plus 1. So 1 I can rewrite it as 3/3. That's going to give me 4/3. So it's going to be 3w 4/3 times divided by 4/3. Plus, this is going to be 4w cubed divided by 3, so nothing really special there. Then 1/2, this I can rewrite it as 3/3. That's going to give me w 5/3 divided by 5/3 plus c. Okay, and remember that we can just flip this over. So this is just going to be flipped. That's just going to be 3 times 3/4 w to the 4/3. And that the other one can stay the same. Okay, and then this is going to be minus 1/2 times 3/5 w to the 5/3 plus c. Okay, if you really can't see, here it is. Okay, now to finish this off, I'm running out of space, but this is going to be 9/4 w to the 4/3 plus 4w cubed over 3. Then this is going to be minus 3/10 w to the 5/3 plus c. Okay, and this is going to be my total answer. Okay, in order for me to figure out whether I got this answer right, I can just always take the derivative of this and I should eventually get the integrand back. Okay, all right, so now for this problem, one of the things that you have to be very careful of is to remember that whenever you see how can I say this? Whenever you see an x to the -1, remember that the integral of this is always going to be ln of the absolute value of x plus c. Okay, so you're either going to see it like this, or you're either going to see an integral of 1 over x dx. That also equals the same thing. Okay, so just be aware of that, of this minor detail. So for this one, okay, so let's go ahead and take the derivative of this. So this one's going to be simple. I'm sorry, the antiderivative. So this one is going to be x cubed divided by 3, because I added 1, plus 1/2. I'm going to add 1 to this and divide it by the total. So adding 1 is going to give me -2. So it's going to be 1/2 x to the -2 divided by -2. This one, we see that it's x to the -1. So that should be ln of x. Okay, so this part is going to be ln of absolute value of x. Minus, okay, so this one is going to be 5/3, okay? But remember, I can write this as times 1, so you technically have a 1 over x there. This is also another ln of absolute value of x. And then at the end, plus c. So you have to watch out for those little things, okay? So let me clean this up. This is going to be x cubed over 3. This is going to multiply together to get a minus 1/4 x to the -2 plus ln of absolute value of x minus 5/3 ln of absolute value of x plus c, okay? You can finish it up here. This is fine. You can combine the ln's and you can make this to the bottom, but this will be sufficient. Okay, I will be okay with this. Okay. All right, now for the last one, what we have is the integral of e to the -7t minus 2 over x plus 4 x to the -5. Okay, so one thing to remember is that the antiderivative of e to the x dx is also equal to, it's also equal to e to the x. And if you want to find the integral of e to the ax, so if you have a number right in front of the x, this is going to be 1 over a e to the ax. Okay. All right, so let's go ahead and do this. Let's do maybe a little on this one. Okay, so the antiderivative of this, well, we notice that there's a -7 in the front, so this is going to be 1 over -7. Okay, so you're going to put that over, and then I'm going to have e to the -7t. Okay, now minus, this 2 isn't going to do anything. Notice that I have a 1 over x here, a hidden 1 over x. That's going to be ln of absolute value of x. Then plus, this one I'm going to add 1 divided by the total. I'm going to have 4x to the -4 divided by -4 plus c. Okay, so what I'm going to have is -1 over 7 e to the -7t minus 2 ln of absolute value of x. The 4's are going to cancel out, so I'm going to be left with -x to the -4 plus c. Okay, and this is going to be my answer. Okay. All right, so that's what basically we did this past week. We did a lot of integration, and then next week we're going to continue on with integration.